Perth Linux Users Group, talking Linux and open source.
Hey everyone. All right, we're going to get started tonight. So thanks for coming. We got a talk on Chromecast today. It's going to be great. But before we get started, I just want to say if you're not already a member of Plug, or you may be a member on Meetup, but if you're online or here, please keep in mind we do appreciate if you sign up and give us $20 or $10 if you're a student and keep the show rolling. That way we can give away prizes and go places and do cool things. We really need your support. And anyway, thanks for coming. Thanks for tuning in. And I'll leave it to you, James.
All right. So I was going to talk a bit about talking to Chromecast, as the talk says. Just as sort of weekend projects for last couple of months, I've sort of been, I was wanting to build up a little app to run on Ubuntu to send video or music through to my television using a Chromecast. Since there isn't any official applications for the Ubuntu phone and stuff, that's something I was finding interesting. I haven't got all of that working yet, but I've sort of had fun writing the software, and I thought I'd sort of talk a bit about how some of the Chromecast protocol works, because I think there's various interesting projects which people could do with them. So I thought I'd share what I'd learnt. So you've probably all seen Chromecasts. There's the first generation and the second generation. They're as far as the software is concerned, they're pretty much identical. I wouldn't know about that. And is that going to look? Sorry, I was saying that there is also a third generation which might be coming out. There's also a second version of the second generation, which is an audio-only one. So rather than plugging into HDMI, you can hook it up to as a 3.5mm audio jack or optical output if you don't care about video. It's basic, and you probably already know all this. It's a device intended to send data from either the Chrome web browser or an Android or an iOS device. And it's primarily marketed as something for just displaying video, which it does quite well, but that's not all it can do. So it's kind of an interesting hardware. It probably looks quite familiar if you've ever looked at the specs for a phone from maybe about 3 or 4 years ago or something. So you've got a dual-core ARM chip. It can do OpenGL ES. It's got 0.5 gig of memory. Interestingly, the first generation device had 2 gigs of storage, and the second generation only has 256 megs of storage. I think this is that they managed to shrink down the install base, and for the kinds of things you use the device for, it doesn't really matter at all. The original devices, they could do 802.11n wireless, and the new ones can do AC. And I guess I've got no idea what the third generation will do if that comes out. But anyway, I expect software-wise it'll look pretty much identical. The device runs Linux, but it's fairly locked down, and I haven't really looked at anything about how to replace the firmware, because that wasn't really something I was interested in. I wanted to develop software which should just be able to run with any off-the-shelf Chromecast device with minimal hacking. One of the interesting things, the Chromecast name isn't just for brand recognition. The device is actually running a cut-down version of the Chrome browser, which is kind of interesting. And it combines that with a message bus, which is how the applications you're running in the web browser or a mobile device will communicate with the Chromecast, starting up a stream and then communicating with the Chromecast while it's doing the stream, so you can do your play, pause, and whatever else. So There's a number of people who reverse engineered the RPC protocol, which is, I'm sort of glad that I didn't have to do this, but one of the nice things, given that one of the sending platforms was the Chrome browser, there's a lot of the code needed to support this actually exists in the Chromium source tree. That's the open source version of Chrome. So quite a lot of that, that takes a lot of the guesswork out of this. So that's quite helpful. So when you plug a Chromecast in and you've configured it to talk on your Wi-Fi network, you've probably seen your device, your sending device can detect all of the Chromecasts sitting on the network. And this is done through multicast DNS, which is also known as Bonjour or ZeroConf or whatever else. And if you've got the Avahi tools on your desktop, you can search for all of the Chromecasts on your network quite easily, just running that command, sort of Avahi browse _googlecast._TCP. And that will tell you the IP address and the port number to connect to, which the port number is always the same, but it could potentially be something else, but generally it isn't. And it also gives you a TXT record, which contains a bunch of extra metadata. So you connect through to the port. If you connect through to the port, which you get through Discovery, you can start up a TLS session, so that's the same encryption you use for secure websites. Then they transmit a binary protocol over this. It's just doing a simple thing of having length prefixed packets. So it's probably one of the simplest framing protocols you've got. And then the packets inside, they actually use Google's protobufs specification to format these. So each of the packets sort of has this, it's set up so each of the packets can have a source and a destination, and it's got some various other things. So essentially what they've done, this RPC system sets up a message bus so you can have essentially multiple clients on the sending side, multiple clients on the inside the Chromecast, and you can direct messages between them. And there's also ways you can also have multicast and broadcast to all clients on one side, or etc. So again, you've got as well as the source and destination, which are represented as strings. You've got a namespace, so you can have different types of messages, and then a payload, which is either going to be binary data or a UTF-8 string. Probably about 99% of the traffic goes through as the UTF-8 strings, and most of that they're using JSON encoded strings. So for a lot of this data which you've got, they've essentially got text encoded as JSON, which you got an object encoded as JSON to a string, which is then packed inside a protobuf, which is then has a big endian integer for the size of the protobuf prepended to it, then sent over SSL over TCP, which seems kind of complicated, but I'm guessing, I guess this sort of was an easy way to set things up, and it does mean that for a lot of the high-level stuff, you don't have to deal with. You can really just deal with the text with the JSON objects, which is kind of nice. As I said earlier, there's the source and destination. There are sources and destinations which are represented as strings. You've got you can send through a special command to create a connection between sources and destinations. And that's basically the first thing you need to do before doing other communication, before sending any other messages. So in general, the first thing you do after connecting is creating a connection between the sender platform and the receiver platform, which is a channel used to configure everything else. So that's sender 0 to receiver 0. So I think the idea was that in the future you might have been able to have you could potentially have multiple screens attached to some Chromecast device, or maybe they're just thinking ahead, but that's how it is set up. So one of the other things, there is an authentication feature in the Chromecast, which I've pretty much ignored because I mean, the device works if you don't use the authentication, but it's there if you care about it. So earlier I said that all the RPC is sent over a secure connection. It uses self-signed certificates, so each Chromecast has its own certificate, which sort of brings up the question, how do you know if you're talking to a real Chromecast? So they've got once you actually establish the connection, there's this system where you can do a challenge response, which will be signed by a key, by a platform key, which is common to all of the Chromecasts. I think the reason they did this is that, in general, SSL is hideously insecure if you're going to have the same key everywhere. So this basically limits the common key to a single communication, which is going to happen over an encrypted session. So that kind of helps. Now, as for why you'd care about if you're talking to a real Chromecast or not, I guess probably one of the best examples is, let's say that you're trying to stream Netflix or something to a Chromecast. That basically involves setting up an application on the Chromecast which will play Netflix, but it needs to have your user credentials in order to talk to the Netflix servers. So your Android device or iOS will that'll send your credentials down to the Chromecast, and then it'll start communicating. Now, if you don't do this authentication step, then how do you know that you're actually talking to your Chromecast rather than something else, and you haven't sent your Netflix credentials to something which could then send them off to Russia or whatever? So I guess it's sort of, if you are sort of dealing with that sort of personal information, then the authentication would be worth implementing, but I haven't really given it a go because the things I was interested in testing out didn't actually need it. So as I was saying, you've got the receiver endpoint, which is the base platform. They've implemented sort of there's a heartbeat protocol so that they can quickly disconnect senders if they drop off the network sooner than what would happen with TCP timing out. And there's another interface, the receiver namespace, which is used for querying the status of the Chromecast and starting applications. So if you're wanting to start an application, you'll send a message with the start, which is sent from sender 0 to receiver 0 with the namespace Google Cast receiver, and the payload is a little JSON blob, which sort of says it's a launch message. You've got a request ID, which is just sort of some unique number, which will be so that you can correlate the return messages with the sent messages, and an application ID, which is just basically a 32-bit hex string. What happens in the Chromecast? It will contact one of Google's servers and say, what does that 32-bit hex string mean? And it comes back and is told, you want to load up this particular web page. So this time it's launched from Google's static content thing. This is static content domain, and this is the default media receiver application. which will then start running in the Chrome browser on the Chromecast, and it'll start listening for commands from over the RPC channel. So the Chromecast then responds with a receiver status message telling you that this application is now running, and it'll tell you that this receiver supports these particular namespaces, so it can understand commands on this media profile and the inject protocol profile, which I haven't actually looked at much myself. And it's also just giving you some status information, telling you the session ID for this, telling you about giving you a unique identifier for this instance of the application, and the transport ID is a new destination endpoint you can use to talk to the application rather than the Chromecast itself. And it also just tells you what the volume settings are on the application. Basically, at this point, everything at this point is going to be will really depend on the application you've loaded up. So, in this case, with the default media renderer, you'd pointed at a couple of video files to render, then tell it to play one of them, and you can pause, fast forward, stop, and everything else. But essentially, it could do anything at this point. And again, this will be done by creating a connection through to the new transport endpoint, which was that Web25, or it'll be different each time an application is launched, and then sending commands which that particular receiver expects. So let's see. There's a big long list of receiver applications which people have written. Pretty much if you browse through the Google Play App Store or the iTunes App Store and look for things which say that they support Chromecast, then they've registered some receiver application with Google, and you'll find and you could potentially load up that application yourself. You probably won't necessarily know how to talk to it, but I know some people have worked out how to make use of the YouTube application. So it is quite possible just to use other people's apps, but of course you're at the mercy of those application developers. They could change those things at any time, and so that's maybe not the best way of going forward. But there's also a couple of standard applications which are a fair bit more stable. So probably the most interesting one is that default media receiver, which is basically a simple video player. And there's also a Chrome tab mirroring app. And then, of course, it's possible to write your own custom applications. So again, the default media receiver, it was kind of interesting just browsing through the list of all the registered Chromecast apps and just seeing how many of them are basically just a styled version of this default media receiver. Because it's basically set up so that you can inject some CSS and change all the images and make it look like your own. So it's quite popular in that sense. This also means that it's very well documented by Google. So it's well documented by Google. So it's quite easy to work out how to talk to the Chromecast, talk to this receiver app. The other one is the screen mirroring app. I haven't actually tried talking to this one at all. So this one's actually an interesting one in that it's not actually implemented using the Chrome browser on the Chromecast, there's actually a separate application which handles the mirroring. I'm pretty sure that you can't ask Google to register a new custom application like this, but I guess this would be an interesting thing if you had a rooted Chromecast and you wanted to register new types of applications, do it using this command line mode. Actually, internally, this screen mirroring thing shares a lot with WebRTC. So it's generally set up so that you'd be sending video in the VP8 codec and audio with Opus, and you essentially do the session initiation over the RPC channel, but then all of the audio data is going to be sent via UDP, just similar to if you'd set up a WebRTC connection in a web browser. Yes, Nick?
How much process time does it take to encode these things?
Well, in this case, the Chromecast isn't encoding anything. So the question was how much time does it take to encode stuff with the screen mirroring? So again, that's going to depend on the sending device. The Chromecast itself, it's just decoding the media which is sent over the UDP connection, and the Chromecast, it's got like most ARM devices, it's got hardware video decoding. I don't think it would be using any hardware for decoding Opus, because I don't know if there is any hardware to decode that, but audio is pretty cheap these days.
Coming from your laptop, whatever, screen mirroring, maybe software?
Yeah, it's probably using software, but again, you're not really. I haven't actually looked at what the Chrome browser is doing in this case. You don't really have much need to compress down very much, because in general you're going to be talking over a fairly fast local Wi-Fi network. So I mean, yeah, most of the heavy lifting for encoding video is if you want to make video small, and you put in a lot of CPU time to make it small in the encoding stage, so it's cheap to decode. But in this case, you could sort of do very mild compression, and it seems, I mean, it works reasonably well. I've done some screen mirroring from Android, and that doesn't seem to cause much of a problem. So yeah, it's,
Mirroring video,
well, this one, it was mirroring a video game, so it was active on the screen, and it seemed to be reasonable quality. I don't think it was full high quality, and it didn't seem to be going at 1080p, but
I think the mirroring by standard is 720p.
okay,
I think. Don't quote me on
that sounds quite possible.
that. No idea.
I don't know. I mean, again, you've got 82.11n. That's 54 megabits. No, G is 54 megabits. N is like 100 or 200 megabits. I mean, this is generally not a problem. Yeah. So again, the other option is to just ignore all the default stuff. You can write your own. Now, Chromecast is a bit of a walled garden, but the walls aren't particularly high. If you've got a Google account, you can register it as a Chromecast developer account, which costs you $5. I think it's probably $5 US, but once you've done that, you can register as many applications as you want. Essentially, you're going to have to write a bit of HTML and JavaScript together and put that on a secure website. You can then enter in all your details on Google's API console, and you'll get back a little 32-bit number, which you can then use to launch your application. There's also some stuff in there which you can use to set a Chromecast into developer mode so that you can test out these applications locally. But again, if you haven't told anyone about your application, then they're probably not going to find it, and it doesn't really matter. I mean, you probably wouldn't really want to be relying on secrecy anyway for these kind of things. Okay. So I guess my original interest here was I wanted to write a little application for my phone. So I'd have so running on the phone, so that if I'd recorded a video, I wanted to be able to just go through Content Hub, so in the media player, I can choose to share a video where I'll get a list of applications which can import videos, and then I wanted to write an application which could hook up like this, so it would accept a video and then look for a Chromecast on my network and then start playing it. So this is kind of why I was interested in the default media renderer, because it sort of it's already built, it's already handles pretty much all of the commands which you're interested in, and all I need to do is serve up my video over HTTP and point it there. So as I said earlier, other people have done most of this reverse engineering. So there's a couple of libraries out there. There's one based on Node.js. There's another one which is written in Go. But for most stuff on Ubuntu phone, the user interfaces are written in QML. And for my day job, I do a lot of C++ work. So I started writing my own, which I guess, well, doesn't need another library, but I thought I'd do it anyway. It's a weekend project, so that's what I was interested in. So there was a couple of speed bumps I had. So on the phone, we don't have any multicast DNS responder. And on your Ubuntu desktops and pretty much any Linux desktop, you'll have Avahi installed. But one nice thing is there is an embeddable version of Avahi, which is the libavahi core library. So I wrote a little Qt Qt wrapper around that, which meant I could create an abstract list model which could browse through all services on the local network matching a particular service type. So I could just say I'm interested in googlecast.tcp, and then I could populate an option selector widget with the names of all those devices, and then pull out the host name and port number. And then I sort of implemented all of this message bus in some C++, and writing with a QML interface to this, so that for the high-level QML stuff, I just dealing with some of the high-level commands which you can send to the receiver, and also be able to program up things like the default media renderer, the protocol to talk to the default media receiver just from JavaScript and QML. I've still got a few bits to do. I've got to set up the web server, and I've got to hook up the Content Hub bits to receive media. And I'm also looking at extending this thing to work with to work on the desktop as well, which would sort of involve writing slightly more useful desktop UI, and probably also switching over to getting it to use the existing Avahi responder on the desktop. I had been hoping to put together a bit of a demo of all of this, but I couldn't get it all working on the weekend, so I thought it would be safer just to sort of have the static slides. So I'm sorry about that, but I do have. It is sort of everything which I've done is. Everything which I've done so far, it sort of. It's enough to sort of show that this kind of thing works, and I thought that this would be enough to get other people interested in writing similar types of applications or coming up with other things which they'd like to do with the Chromecast. So I think one of the ideas which I had, which I'm definitely not going to have time to implement, would be you could set things up so that, say you're at a conference, people often have a bunch of TVs set up displaying the current program or wanting to stream some video or something. So a Chromecast could offer a simple way of using off-the-shelf hardware which is getting all of its security updates and can just sort of sit behind the TV, and you could set up a bunch of Chromecasts on the network and have a central server which could detect all the ones as they come up on the network and get them to load up, whether it's a video stream or just some simple HTML or... sorry, do you have a...
Would you be able to do that via multicast?
I don't... Probably not,
Okay.
but maybe.
'Cause that would make it, because if you do it via multicast, that makes it much more scalable. You can have like 50 TVs without any extra bandwidth.
So, again, the question was about whether you could use multicast here. As all of the video rendering, essentially you've got a web page with a big full screen video element. If you could do multicast within the Chrome browser, then maybe you could do it with a Chromecast. I don't know if I don't know if you can do that. Everything which I've seen so far was loading up an HTTP URL, and there are various adaptive streaming protocols that can use, like HTTP live streaming and various others, but in general these things have been unicast because the primary end users for a Chromecast is streaming media from iView, Netflix, etc., and multicast really doesn't work over the internet, unfortunately. So I guess if it did, then it would be it'll be something which they'd look at, but I really don't know if they have.
Wireless with multicast, you'll be colliding anyway, so
Sure.
You could potentially maybe
You can get me from
WebRTC.
oh yeah, but
Sorry?
Yeah.
WebRTC stuff and having there's some combo conventions. Anyway.
Yeah, I don't know if you could do the WebRTC stuff, but again, if you're doing peer WebRTC stuff, that's still mostly unicast, isn't it? Anyway, the other interesting things, since this is sort of more than just video, you can, just like in a web page, you can do some dynamic, you can hook up some dynamic code. You don't have to just sort of either be displaying video or static content. You could run a little. You could even be running like a little HTML game or anything on the Chromecast. I know Google's sort of been pushing this a bit, but I don't think there's really been much take up for writing HTML games. But that's kind of that's the kind of thing which you could do. So those are just a couple of the ideas. I'm sure there's other people who've got other ideas about this. So I did have a couple of the resources here. There's the little Qt code I've written just sitting up on my GitHub page. There's a Node.js Node.js based cast implementation, which is written up as a library, plus a couple of scripts to run some applications for sending direct for talking to the media renderer and a few other applications. There's the Go implementation. Oops, sorry, I didn't put a little proper title there. And there's this other CRcast project, which was looking at being able to implement the receiver side of the Chromecast protocol. But of course, this one, I believe they've got enough stuff there which you could use to talk with some of these unofficial sender client libraries, but it won't talk to the official stuff on Android or Chrome because they don't have the platform keys embedded into the official Chromecast devices. But anyway, that was most of the stuff I had on my talk. I had been hoping to have a bit more stuff about my application, but I couldn't really get it all working, unfortunately. So I guess I was wondering, does anyone have any questions of it? Will?
The output of a Chromecast, is it all protected by DRM, so
HDCP.
HDCP? Or like, so if you just wanted to capture someone's screen, could you just send that over and then maybe plug it into a board and then put that into another video stream?
I believe it only does HDCP when it's showing protected content.
Okay.
So when you're doing plain screen mirroring, I'm pretty sure that's unencrypted.
Oh, it's good to know.
Right. I didn't know. I didn't know the answer to that.
That's all right. And the other thing, this is an interesting note. The third generation Chromecast I mentioned, hopefully it's going to be capable of playing back 4K video.
Okay.
So Google's doing a huge event on the 4th where they're unveiling a bunch of stuff, and the new Chromecast is expected to be launched there.
All right. So, yeah, I mean, I think the current Chromecasts, they're definitely 1080p only. I mean, it's fairly medium power ARM chips, which can only really do the 1080p video due to the hardware decoders. So.
The other thing, I don't know if you mentioned it, but the other thing that's really interesting about the Chromecast is just the price.
Yeah.
Because they are disgustingly cheap at like 50 Australian dollars for the second gen.
Yeah, the other nice thing is you can just go down to pretty much any consumer electronics store to buy a new one rather than ordering a Raspberry Pi or something and waiting a month or something for it to arrive. So, I mean, if you did sort of set up a project using these things and you suddenly needed 5 more of them or something, then that's very easy to set up.
Something you looked at, you said each device has its own SSL certificate. Is that static for the life of the device, or is it like if you do a factory reset, does it generate a new one?
It cycles the certificate every day, so yeah, even if you're just leaving the certificate, even if you're leaving the device plugged in and turned on all the time, which usually you do because it's fairly low power, it's going to be changing it each time. It's set up so that yeah. But again, it's rotating it all the time. In the multicast DNS reply, it'll tell you what the fingerprint of the certificate is, but again, so that way you can tell that you're actually talking to the device which sent that multicast reply. But again, that in itself doesn't give you any security because anyone can generate a self-signed certificate. It's the second stage of using the authentication.
And not some other device.
Yeah. In fact, I think the authentication stage is the only thing which uses binary messages. Everything else I've seen was JSON encoded Unicode text.
Does that mean the platform key is somewhere on the device?
Probably. I haven't done anything to try and disassemble the firmware. I would imagine they've either. I know some people have disassembled. They've recovered firmware for some of these things. I haven't really seen anyone saying here's where you can download a copy of the private key. But in general, it's pretty easy to get access to the. Let's see. All right. Anyway, you can get access to the public key, but I think this private key is fairly heavily embedded and probably doesn't. If I was setting these things up, I probably wouldn't include it in the firmware updates. Yeah. You'd want to have it so if it suddenly goes missing, then the device can't get it back. Yeah. Yeah. Is there any other questions? All right. Okay.
Borrow your ear. Thank you. Hey guys, thanks for coming. Oh no, I forgot my dates on my phone. So we're going to, first we need to give thanks to SpaceCube for letting us use this space. They let us use it every month, and we appreciate that they're continuing to sponsor us. If you have any questions regarding SpaceCube, just ask Paul, and he'll help you out. Also, Tuesday we have a committee meeting. You can join us online. There's more information on that on our website, and you can view it on Meetup. Monday. I always think it's Tuesday, but it's Monday. Scared me. Yeah, no, it's yeah, thank you. Thank you. No, it's every Monday, and it's at 7:30, and you can join that on our Mumble. So mumble.plug.org.au. Also, we have coming up is Plug in the Pub for September, which is, again, on a Monday, but Monday the 26th of September at 7 p.m. Also, we have been doing a bit of work around. Apologies for the crazy camera work in the beginning. We're down a camera. We've been doing some AV work. And if you're interested in working on that, just let us know. Join the AV mailing list or join us on IRC and chip in. And the admin, the admin mailing list as well. So we've also been working on some admin projects as well. We've been working on the website, which it's coming along. It's now viewable. Well, it's been viewable on GitHub. You can view it there. Submit any changes if you like. But we're moving along with that. We're also, if you're familiar with Ansible, that would be a great help. So join us on IRC and chat with us and submit emails and all that fun stuff. And again, if you haven't already, sign up as a paying member. It really helps us. So that's all. Thanks for coming, everyone. And for those of you who are watching the video, thanks for tuning in. All right, I'm Will, and good night, everybody.